Hello everyone. Today's talk will be about using R to create TLFs for CSRs and submission. My focus in the presentation is going to be basically on analysis, summary analysis tables, but this applies to listings as well, whereas figures can be handled in a pretty much similar way. So agenda-wise, there's a broad agenda, what to expect from this presentation, and how do we do it? How do we currently do how do we currently create tables and listings within SAS, and how we can do it in a similar way in R, and which are the advantages of using one versus the other? Is there any? Is there none? And then one final take on whether does R in the end rival SAS? So can we use R instead of SAS in our daily work? And this is going to be it's going to be mostly from a statistician's perspective, but as I will mention later on, as statisticians, we're quite involved with programming activities, so I think most programmers will benefit from this as well. So in this presentation, we're going to discuss a practical example of how to create a specific summary analysis table, whose shell will be presented later in the next slide. We're going to show some R code and illustrate how it can be flexibly used to create a good-looking output, similar to what we do with proc reports in SAS. And the code will provide some hints and tips and some ideas on how to make the best out of the tools which R offers us. And we'll do an explicit comparison with the main reporting features of proc reports. So how can we, which R code would we need to do to create the same output features that we would create using SAS specific programs? And then, as I mentioned, a perspective from a statistician on why we should be using R in the industry more often and more in a more, let's say, detailed manner. So this is the target. So this is the table shell which we've been given by our management. So the analysis plan details this analysis, and this is the shell. I'm going to present this based on data from a leprosy treatment study. In the paper, there is a reference to the source for the data. In this study, there were 3 treatments, A, D, and F. F is like the control arm, so we're going to compare drug A and drug D versus drug F. And we want to see a reduction in the number of bacilli, of leprosy bacilli in the samples which we're collecting from patients. So we're measuring baseline and end of treatment, and then we're going to do a simple analysis of covariance. Now, the way we would do it in SAS would be first to use like proc mains, proc summary, univariate, whatever it's your favorite procedure to create the summary statistics for the baseline and end of treatment for the 3 drugs. And then one between GenMod, GLM, mixed, or anything to create the least square mains estimates with their differences, confidence intervals, and everything else. And once we've got these two stats procedures, which are the bulk of the table, the backbone of the table, we would proceed to do some manipulation or data wrangling to make sure that the outputs are all reshaped such to follow the table shell layout. And once we've got our data set with the proc report with some adds on to make the table look correctly aligned, correctly spaced, correctly indented, correctly bordered, correctly framed, and everything else, that will generate the final output. So once we do this in SAS, I'm not showing the code, but there is the proc report code is available in the paper. This is what it looks like. So the table looks nice. We've got our protocol name, page number, table title, table contents, the footnote with the date and time when this was generated, by which table created it. So everything is traceable, everything looks as it should. Now, how do we translate this table? How do we translate what we've done with SAS into R? Now, following the same approach as we did for SAS, so the summary statistics can be calculated in a multitude of manners. In this example, I've used the ddply package functionalities to create a compact data frame which stores the mean, the standard deviation, and everything with already a format applied for both time points. And there's other ways you can do it within R. This is the most compact and the most straightforward way to add some by grouping, as is the case. But you know, whichever is your favorite way of programming, you can apply it within R, so it's not a big deal. And also, estimating DLS means is easier than it was even only a few years ago, because this package EM means has been created, which allows you to estimate least squares means, which is something which is not by default created by our procedures, because it's least squares means is something which is very much SAS specific. This package, however, receives objects created by modeling functions in R and allows it to extract least squares means depending on the type of least squares means and control and comparisons you want to extract. So it's a very compact and neat package, and it's allowed it to extract a multitude of results in a very simple way. And once we've done this, we use the SQLDF package, which uses SQL syntax similar to ProcSQL or standard base R to do the manipulation which we need to do. And once we've done this in a way which is not that much different conceptually from what we would do in SAS, we use these two packages, FlexTable and Office R, to do the actual reporting. So to translate the data frame which we created with the 3 steps above into a nice, good-looking output within whichever device you want to. So let's say a Word document. Now, I'm going to concentrate on this rather than the steps above. There are some comments on the 3 steps above also in the paper, but for presentation's sake, I'm going to concentrate on how you can create good-looking outputs from a reporting perspective. So this is the home page for the FlexTable package. As you can see, it allows you to create HTML, Word, and PowerPoint documents. I'm only going to discuss Word documents creation here. Now, this is a very simple package to use. The key point is a class of objects named FlexTables, which means that the first and foremost thing you need to do is to take your data frame, which you want to display as a table. You need to convert it into an object of class FlexTable, because then you will be able to apply loads of functionalities to it, formatting, aligning, whatever you name one, you have it. And then the Office R package will be used to export this object into an external document. So the good thing is that the functions, once you've created this FlexTable object, you can apply styling functions. You can add specific things to the object. So you can add titles, you can add footnotes, you can add alignments, you can add column widths, row heights, whatever. And then you can apply different styles to different sections. So you have a body section, a title section, and a footnote section, and you can apply things to different parts of the object itself. And you can still do this like you do with normal R for a specific cell of the object, which means you can, if you want to modify something for the second row, third column, you just apply a function to the object, selecting the second and third row by means of the square bracket 2, 3, close bracket, apply function. And that is going to, you make sure that you apply something not to the whole table, but only to the specific cell. Be sure to, you might need some trial and error at times, because the ordering of the functions does, can have an impact on what table looks like. So to create the table here, this is the full code. So summary 07 is the data set, is the data frame which stores the results. And so with this first section, we define columns, rows, and features like width, height, alignments, and everything else. With this, we add titles and footnotes. It's interesting to know that this function adds things on top of what is already available, which means that the thing which you want to be displayed at the top has to be, in this case, has to be added at the bottom, not as first, which means that in here, the table title will go underneath the page 1 of 1 line. But given the way the function works, you need to specify this afterwards. So this is going to be added on top of this, and so forth. We need to fix the horizontal lines as well. So we need to make sure that we only got horizontal lines that wrap the headers, the header columns. And then we can change the font size, we can change the font itself, and there's plenty of other options which are not used here. Once we run this, and you notice that we can use, this good thing about this package is that it allows the use of this pipe, like in the tidyverse set of libraries, which means that you can apply basically you're applying this function is being applied to the object created by this FlexTable function, and this is going to apply it to the result of this plus this and so forth. So which means that you don't need to constantly have a left-hand side operator before the assignment and the function. You can only specify this once, which makes for a much neater and lighter code. And once we've done this and we've created the FlexTable object with all its features, we just export it with the official package. So we need to have a base document, an empty Word document, for instance, which is oriented the way we want it to be oriented. So with, let's say, landscape orientations and narrow margins. Then we use the read_docx, the read_docx function with the name of the base empty document to open the connection to that document. Then with the body add FlexTable and the value equals the FlexTable object we want to add. We explicitly say add this FlexTable to this document, and then we print it. We print it to a document. We print this doc, and we send it to this table1.docx, which means that once we've done this, in the folder where this document was available, we will see that there's also a table1.docx document. And this is what it looks like. It looks neat, it looks nice, everything is in its place. And, you know, it might seem a lot, but this is not that much different in terms of amount of programming than what you would need to create the same table using proc report after all. And the good thing is that most of the things that we usually do with proc report, I mean, generally are available within FlexTable. We can things like aligning and defining column features, which usually is done within the define statement, here can be done within a function, and you can apply different widths, different length to different columns. You have function which allow you to specify how you want the horizontal, where you want the horizontal lines to show up. So I've added them here, and you can add the header lines and footer lines, and these are actually added as additional rows at the end of the object, really. And then there is the chance with add header row and the call width option, you can have the columns with headers which span across multiple columns. So if you have an if you want to report results from a model, you have like estimate and confidence intervals, then you can add the overarching header, which can be model results, and underneath you write, you've got your two column specific headers. With this function, you can do it. Well, there's two things which FlexTable does not allow to do straight away. One is the skipping, which means when you have break after a variable skip, where you say you cannot, that would usually insert a blank line. That's not something which you can do. To do that, you need to add the blank line in the source dataset, which is fed into the FlexTable, and the multiple pages. FlexTable does multiple pages, but not the way we usually see them, because the way we usually see them is with the column header being replicated across all the pages, whereas FlexTable would not do that. It would simply print the remainder of the table to another page. In order to fix this, we can write a function ourselves. This is incredibly easy to do with R, much easier than with SAS, and it really takes a minimal amount of program to create a function that does exactly what you want. The key point is to explicitly use, say, print the document, print a subset of the document depending on the section which you want to print on the output file. So we need to create a page variable in the dataset, say page 1 and 2, depending on how you want to page 1, page 2, depending on how you want to split the report, and then write a function that iteratively prints the rows where page is equals to 1, and then afterwards prints the page where prints the dataset where page equals to 2, and ensure that that goes to different pages. And we can do that using this body add FlexTable function. So the full function code is available in the paper, but this is the key part. So once you've started this, there is a do loop. This is all encased in a do loop, in a for loop, sorry. And basically, it tells it that when the page is equals to 1, so I here is the page number, then do as we did before. So open the connection to an empty document, add tape this summary, add this. Whereas this object has been created only selecting rows where page equals to 1 in the source dataset, and then print it out. Otherwise, if page is not 1, is everything else, so from 2 onwards, open the document which we created when we printed page 1, add the page break, and then add the FlexTable object. And once you do this and print everything out, you end up with a table with an object which has in this case 2 pages. And on each page, the title and the footers and the header have been replicated as we would usually see. The output of this is available in the paper as well. Now, I think it's very clear that yes, R does rival SAS ultimately. There is a great flexibility, which means that if something is not available, you can usually tweak an existing method or create your own method to do it. SAS is not always that straightforward, you know. That means that, as I showed you here, if you have a problem with the way something is displayed, you can create a function which can be used as a wrapper for different things for different functionalities that the software already allows you to use, but not in the way you would like to use them. And now with this tidyver, the tidyver being more and more say documented, being widely used, and the presence of SQL-like features, really what we do, we can create tables and listings literally in the same conceptual way as we do within SAS. So the transition from one to the other is not even that difficult. You need to learn a new programming syntax, but the logic behind is different, but you can still follow the same process, the same flow. And R is very efficient when it comes to computer-intensive methods. Things which can take ages to program within SAS is very easy to do within R, like bootstrap or permutation and things like that. And you've also got loads of statistical methods, which is the statistician's perspective I was mentioning before. If you've got there is such a wealth of statistical methods that you can apply, and they require somebody with the statistical expertise to use, which means that there's not a chance of fitting a wrong model, because a model wrongly specified will simply not work or would give nonsense results. And one key point is many argue that there are differences between the results, and some talks at the Fuse Connect are about differences between R and SAS, but in many cases these differences are due to different defaults, optimization algorithm being different, default settings of the softwares being different, and so the differences themselves are not real differences, so to speak. The results are equally valid. One just need to look into the documentation and see how to apply the same settings to both softwares, and then the results in most cases would match. So the final remarks are that R can create nice and good looking TLFs, and this can be it can do this in a rather efficient and let's say similar way as SAS does. So the steps would be similar, the logic would be similar, the programming philosophy is different, but the transition is not, it might be not that tough ultimately. And the thing which I would like to stress on is that many times we do compare R and SAS merits within the industry, but we do not account for the fact that SAS has been used for decades in the industry, so we know it inside out, we know exactly what it does, how it does it, and how quickly it can do it. But this is not quite the same when it comes to R, because it's not been used that much. So with the spread of R across the industry, I support the fact that experience will be gained on how R works and how it can be used in our daily work. And so we will, moving forward, we will be better able to assess whether it can be, whether, you know, its capabilities can be fairly compared to those of SaaS, which at the moment, because at the moment the comparison is not really, it's not completely fair because of the different experience base here. And then the final thing is, obviously, it all boils down to using the tools which we have in the best way which we can. Not all tools are good for everything, but in general, as you can see here, I believe that once you've experienced R, you will see that it's certainly one of the best tools available for performing our daily work. And I really sincerely hope that this talk have, if not enlightened your mind, at least has broadened it and made you consider the use of this software in your day-to-day work.